Let ABCD be a rectangle. AB equals 30. BC is equals 28. Point P and Q lie on BC and CD respectively, so that all sides of triangle ABP, triangle PCQ, triangle QDA have integer lengths. What is the perimeter of APQ? Let's draw a rectangle here. We have ABCD rectangle. AB is 30. BC is 28. And we have P and Q lie on BC. Let's say we have P is here. And let's say Q is here. We have triangle ABP. We have to connect AP. Triangle PCQ, this triangle. These are all right triangles since we have a rectangle here. And finally, QDA, this right triangle. These have integer side lengths. We are looking for the perimeter of APQ. Since we have integer side lengths and we have right triangles, we should try the Pythagorean triples for this problem. And the well-known triples are 3, 4, 5 triangle, 5, 12, 13, 8, 15, and 17, 7, 24, and 25. These are the well-known Pythagorean triples, and let's start with the ADQ triangle here. And opposite sides are the same in any rectangle. We know that AD equals 28. 28 is a leg. So when we look at this triple, 28 is a multiples of 4, 28 is a multiples of 7. But if it is 7, 24, 25, 7 times 4 is 28, and 24 times 4 is more than 30. So we should apply 3, 4, 5 triangle. If this is 3, 4, 5 triangle, the other sides should be, this is 4 times 7 is 28. The other leg is 3 times 7, which is 21. And the hypotenuse is 5 times 7, which is 30. 35 is the hypotenuse for that triangle. And let's focus on the second right triangle, which is we have a leg 30 here. Integer side lengths, leg is 30. And 30 is a multiples of 3, a multiples of 5, and multiples of 15. And 30 is the length of the rectangle, and we have a width of 28. If we say 3 times 10 is 30, then 4 times 10 is 40. That's more than the width of the triangle, so this is out of option. What about 5? 5 times 6 is 30, and 6 times 12 is, the width is more than the length. So we should try this triangle. 15 times 2 is 30. 15 times 2 is 30. Then the other leg should be 8 times 2, which is less than 28. 8 times 2 is 16. Then the hypotenuse is 7 times 2. We just scaled by to 8, 15, 17 triangle. 17 times 2 equals 34. And finally, we should check the other right triangle also. Should apply the Pythagorean theorem, the last right triangle here. Let's check. Should be integer side lengths, which is QC equals 30 minus 21, which is 9. QC is 9. And CP is equal to 28 minus 16, which is 12. And we see that this is 3 times 3 is 9. This one is 3 times 4, 3, 4, 5 triangle, which is scaled by 3. And this is 5 times 3. 3 times 3, 3 times 4, and 3 times 5, which is 15. So all the triangles are integer side length, and this should be our triangle now. The perimeter of APQ equals 35 plus 34 plus 15. That equals this 4 times 5 is 9, 9 times 5 is 14, 3, 6, 7, 8, 84, which is option A is our answer.